In this video, we're going to see how to perform some security tests against flash files included within websites. We will see how we can gather information from source code analysis and how we can fuzz the application in order to find vulnerable injection points. The target application is hosted on the following URL. Before performing any operation, let's start Burp Suite in order to intercept all of the messages between the flash file and the server, and then crawl the web application. With Burp running, let's go back to the web application and let's navigate it. After the login page, we are redirected to the main page of the web application. Here, we can navigate a few more pages. Let's go back into Burp Suite and see which messages have been intercepted. In the sitemap, we can see the page named login.php with the username and password provided. Other files named services.html, services.php, and services.sfw have been found. Moreover, the flash file accepts two parameters named par and redirect. In order to perform security tests against this file and its injection points, we can use software by Adobe named SWF Investigator. This tool allows us to load external and local SWF files in order to extract information, disassemble the application, perform security tests such as fuzzing the application searching for XSS, and more. The first step is to load the SWF file. Since it's on the remote server, we have to provide a URL. Let's click on File menu, then Open URL, and let's copy the URL to the SWF file. Once we confirm the URL, the tool fetches the file in order to obtain some information. On the top of the screen, we will find information gathered from the SWF header, such as the version, the compression type, and more. In the bottom section, we can find listed the exported classes and file tags. We can also navigate file tags in the Tag Viewer panel. The tool offers a very useful feature, the disassembler. This allows us to see the code behind the SWF. The tool also permits us to search keywords within the source dump. Here we can start searching for keywords that can reveal useful information. For example, let's search the string login. Here we can see that some variables have been declared. If we continue searching the string, we can see that some useful information is available. Here's the name of a TXT file, and the content of the variable login database, and the content of the variable login password. Let's try to open the file from the browser in order to read the content. So let's copy this file name and paste it into the location bar of the browser. Here we are. The file is in the main folder and it is accessible. Moreover, some credentials are stored in it. The disassembler is very useful because it allows us to check the code behind the application. We've seen how hard-coded information can be revealed. Another useful tool within SWF Investigator is the XSS fuzzer. We've discovered from Burp that the flash file accepts two parameters. We can try to fuzz these parameters in order to detect if they are vulnerable to XSS. The XSS fuzzer tool needs to load a local file. So let's go back to SWF Investigator and click on File, Save SWF. This allows us to download the flash file on our local machine. Now we can go back into the XSS fuzzer and load it by clicking on Load SWF. In the second field, we have to specify the flash vars that the flash file accepts. This will allow the tool to know which parameters to test. In Burp Suite, we can see the parameter names. We have to use par and redirect. So let's get back to the XSS fuzzer and let's provide these parameters. We can choose a file from which the tool will read the payloads to pass to each flash var. The default file is named xssstring.txt and contains the most common XSS payloads to test. We can edit this file in order to use our custom payloads. The default allows script access property for SWF content in the same domain. If our content uses an allow script access value of always, we can check this checkbox. Once we've configured all fields, we can start fuzzing by clicking on this button. During the scan, each parameter is tested against each string stored in the xssstring.txt, and in the bottom panel, we can see the logs and the status of the fuzzer. When the scan ends, we can see the results within the Output tab. For each parameter provided, we can see the list of the payloads used during the fuzzing phase. Moreover, a green icon indicates that the vulnerability has not been detected, while a red one indicates that the parameter is vulnerable to XSS with that specific payload. In this case, by clicking on the red icon, we will have further information about the vulnerability in the right panel. From these results, it seems that the parameter redirect is vulnerable to XSS. We can then double-check this vulnerability by opening the URL in our browser. So the URL is the following: where for the parameter par, we will use a simple string like the username, while for the affected parameter, we will use a JavaScript alert which will print our cookies. As we can see, it works. This means that the flash var named redirect is not sanitized and it's vulnerable to XSS. Another useful tool within SFW Investigator is the cross-domain tester. Cross-domain tester allows us to test whether our cross-domain policy file will allow loading from a specific domain. In the top box, we have to enter the domain that we want to attempt to load. For now, let's leave the default one and let's click on the Remap button. This will load the cross-domain tester in the security context of this domain. Now we have to configure the URL. Here we have to insert the site that hosts the cross-domain policy file. In this case, let's insert the login page of the web application. We can leave all other boxes blank and run the test by clicking on Submit Request. In the right panel, we can see the output of the request. In this case, the tools tell us that the policy file doesn't allow this type of request. Let's then open the file named crossdomain.xml on the server and see what it looks like. As we can see, the policy allows access only from subdomain of the domain flash.site. Let's then go back in the cross-domain tester and let's change the domain with something like this. Now let's click on Remap and insert the same URL as before. With these domain settings, we should be able to read the content. Let's then submit the request, and as we can see in the output panel, we are able to show the content of the requested URL. In this video, we've seen how to detect vulnerabilities against Flash web applications by testing cross-site scripting and performing a simple source code analysis. The source code analysis allows us to find useful information about the web application. Moreover, we can search for known vulnerable functions, or we can figure out the behavior of the application in order to perform more specific tests. If you manage to disassemble the application, the source code will probably reveal information useful to your engagement. And that concludes this video. Thanks very much for joining us.